Hello, welcome back on my YouTube channel. Welcome back on my explanation or discussing regarding mathematics paper 4 in year to 2021, yeah, February March. Syllabus 9709 slash 42. Yeah. Okay, this is paper 4 mechanics. Yeah. So actually we have 1 hour 15 minutes. Let's we try by one, yeah, number each number, and this is we have about seven numbers. Yeah. Okay, let me check one by one. Okay, question one. Two particles P and Q of masses 0.2 kilogram and 0.3 kilogram respectively free to move in a horizontal straight line on smooth horizontal plane. P is projected toward Q with speed 0.5 meter second minus 1. At the same instant, Q is projected toward P with speed 1 meter second minus 1. Yeah. Q comes to rest in the resulting collision. Find the speed P after collision. Okay, let's say we have P and Q, yeah, masses, yeah, this P, yeah, so P and Q, yeah, in the horizontal plane with smooth, yeah, there is no friction. Yeah, let's say this is P and this is Q. P towards to Q with velocity Vp is uh, 0.5 meter second minus 1. Yeah. And Q also toward to P with velocity 1 meter second minus 1. Yeah. Its mass between P and Q. P is 0.2 kilogram and Q is 0.3 kilogram. Yeah. At the same instant, Q projected toward P with speed 1 meter second minus 1. Q come to rest. Yeah. So you can see this come to rest here after they have collision. So maybe we use momentum conserve here. That mass P times Vp plus mass Q times Vq equals to mass P times Vp after collision, yeah, mq Vq after collision. MP as 0.2 kilogram, yeah, and Vp is 0.5, yeah, plus MQ is 0.3. VQ, remember that Q is toward to P, so when P is positive, yeah, go to the right. So Q is negative because go to the left, yeah. Negative 1, yeah, equals to must be 0.2, uh, and then we need to find Vp after collision, yeah, plus MQ is 0.3, yeah, and they said about VQ after collision is rest, yeah, so we can say this is 0, yeah. Okay, so this is 0.1, yeah, negative minus, yeah, minus 0.3 minus 0.3, sorry, uh, equals to 0.2 VP after collision. So VP equals to, here is 0.2, yeah, negative 0.2 divided 0.2. So VP equals to negative 1, yeah, meter second minus 1, yeah. It means VP is bounce back, yeah, go to the left, yeah. Okay, that's it. So the answer is 1, yeah, meter second minus 1. That's it. Okay, done question 1. Yeah, and we see other question. Oh yeah, don't forget to subscribe, yeah. uh, I need you to subscribe right now. And we continue to number 2. Number 2 is car mass 1400 kilogram is traveling constant speed. Okay, maybe we can uh, like up the strike hill inclined at alpha to the horizontal, where sin alpha is 0.1. Yeah. There is a constant resistance force of magnitude 600 Newton. The power of car's engine is 22,500 watt. Yeah. So that the speed of car is 11.25. Okay. Okay. When we have inclined route, yeah, this one. So we have alpha. They ask me sine alpha is 0.1. Yeah. So when this is, let's say, car, they have a mass 1400 kilogram. Yeah. And resistance force magnitude 600. Power of car is okay. So the first one is so that the speed of the car is okay. Um, wait. First we have weight, yeah, as the mg, and we have also this is mg cos theta, yeah, because of the angle alpha in here also cos alpha, yeah. And we see we have also here as a mg sine alpha. Then when they go with the driving force, yes, this is driving force of car, yeah, and they have resisting force R, yeah, as 600 Newton. Okay, so on the constant speed, yeah, on the constant speed, yeah, this total force equals to 0, yeah, yeah. So like driving force, yeah, minus R minus mg sine alpha equals to 0. We have power, yeah, maybe here, yeah, power, same thing with force times velocity. So force, it's mean driving force, yeah, power equals to driving force times velocity or driving force equals to power divided velocity. Yeah. So we can change this is P divided V minus R minus mg sine alpha equals to 0. So from this, yeah, um, P divided V equals to R plus mg sine or V equals to P divided R plus mg sine alpha. Yeah, uh, we find P is 222,500 and R is 600 Newton and mg sin is 1. Let's say we use G is 9.8, yeah, times sine alpha. Yeah, I calculate first. Yeah, sine alpha is 0.1. So maybe if we use gravitational acceleration as the 10, yeah, uh, here is 10, yeah, uh, yeah, 10 sine alpha is 0.1, so we can cancel about this one, yeah. So this is something to 22,500 divided 200. Sorry, two 2000. Yes, equals to 11.25. Yeah. Okay, this is equals to 11 point. Oh, sorry, 11.25. Yeah, meter second minus 1. Yeah, that's it. Uh, Same, yeah. Profit. Okay. Okay, I hope you understand. And again, please subscribe. Yeah, my channel. Please subscribe. Oh, still have question B. Yeah. The car moving with speed 11.25 meters second comes to section hill which inclined at 2 degree to the horizontal. Okay. Given that the power and resistance force do not change, find the initial acceleration of the car up this section of hill. Okay. Again, this is about total force equals to ma. Yeah. Then we see on this diagram. Yeah. Total force equals to driving force minus mg sin minus r. Yeah. So we back here. This is driving force minus r minus mg sin 2 degree, ya, because this is 2 degree, yeah, 2 degree to the horizontal. Uh, so this is equals to ma. Driving force we have P time V, yeah. P time V. Oh, sorry. Driving force is P over V. Yeah. So here is P divided V minus R minus mg sine 2 degree, not 20. Sine 2 degree, yeah, equals to ma. Power is to 2500. Yeah, still same. With velocity is 11.25. Resisting force is 600 constant, yeah. Minus mg is m is 1400. G, let's say we use 10 and sine 2 degree. Again, sine 2 degree equals to 1400, mm, 225, 200 months. With sine 2, okay, minus, okay, divided, ah, this is about 0.65. Yeah, we get B, yeah, answer about A, this is about 0.65, yeah, meter second minus 2. Initial acceleration, yeah, yes. Okay, then I hope you understand about this explanation. Uh, and please don't forget to subscribe. Yeah, subscribe this channel. Again, we continue to the next number, number 3. Whoa, what is it? Number 3, we have diagram of PRQ 60 degree, 30 degree. Okay, a particle Q is of mass 0.2 kilogram is held in equilibrium by two light inextensible strings PQ and QR. P is a fixed point on the vertical wall and R is fixed point on the horizontal floor. The angle which strings PQ and QR makes with the horizontal are 60 degree and 30 degree respectively. Yeah, see diagram. Find the tension in the two strings. Okay, this is on the equilibrium, so we can say we can use the formula of Ohm's law. Sorry, of Newton's first law. Yeah, Newton first law is Newton first law is total force equals to zero. Yes, between x on y or hmm, yeah, Newton first law. Yeah, we will use this. Yeah, Newton. Uh, okay, on the x equals to 0, also on the y equals to 0 too. Okay, okay, but we need to draw the diagram into x and y direction. Yeah, let's say here, yeah, let's say this is tension R and this is tension on the P. We have tension P on the x as the TP cos 60, and on the y we have TP sine 60. Also R, we have here as TR sine 30, and here is TR cos 30. That's it. We see first about on the x, yeah, total force on the x equals to 0. It means, yeah, TP, yeah, cos 60 minus TR cos 30 equals to 0. Yeah. Cos 60 is a half, yeah, a half TP negative. This is a half root 3 TR equals to 0. So we can decide that TP is uh, or 3TR. Yeah. Okay. Now on the Y, total force on the Y equals to 0. Oh my god, we have other force, yeah, about weight, yeah, because they have 0.2 kilograms. So we can put also here, yeah, plus mg. Uh, so on the Y, yeah, TP sine 60 degree, yeah, minus TR sine 30, yeah, minus mg equals to 0. So let's say when we get TR first here, TP is root 3 of TR, and then sine 60 is a half root 3, yeah, TR, and sine 30 is a half, and mg is 2, yeah, 0.2 times gravitational acceleration, yeah. So let's say this is 0.2 times 10, yeah. Okay, so here this is 3 over 2 TR, right? Yeah, minus a half TR, yeah, minus 2 equals to 0, or this is 2 per 3 over 2 minus a half, same thing 1, yeah. So TR equals to 2 Newton. Yeah. Okay, we get about TR. Now about TP. Yeah, back again. Yeah, TP is root 3 TR. Yeah, TP is root 3 TR. Yeah, TR is 2. Yeah, so 2. Yeah, same thing with uh with, uh, with this is about 2.46, sorry, 3.46, 3.46 Newton. Uh, that's it. Okay, done. Yeah. Okay, thank you for your watching until this number 3. Yeah, and please again and again subscribe this channel. Yeah, subscribe this channel. We continue to number 4. Whoa, what is it? See on the diagram, uh, An elevator move vertically supported by cable. The diagram shows a velocity time graph which model the motion of the elevator. The graph consists of two straight line segments. Okay, the elevator accelerates upward. Yeah, from rest to speed of 2 meters second minus 1 over a period of 1.5 second, and then travels at this speed for 4.5 second, yeah, before decelerating to rest over period 1 second. The elevator then remains at rest for 6 seconds. Yeah. 6 seconds means from uh, 7 to 13. Yeah. Before accelerating to speed of v meter second minus 1 downward, yeah, over a period of 2. Yes, yeah. The elevator travels his speed for a period 5 seconds before decelerating to rest over a period. Yeah. Question A. Find the accelerating of elevator during first 1.5 second. Oh, this is easier. A is change of velocity divided change time. Yeah. Velocity, this is from 0 to 2. Yeah. So mean 2 minus 0 divided 1.5. Yeah. This is about 6. 1.33, yeah, this is about 1.33 meter second minus 2, yeah. The acceleration on the first time 1.5 second. Question B. Given that the elevator starts and finishes its journey on the ground floor, find V. Okay, because the elevator starts and finishes its journey on the ground floor, it means the distance is same, yeah. Or when we see the diagram, yeah, the area on the left side, yeah, is equals to the area of the right side. Let's say here, yeah, area this area until 7 second, it's equal with this area from 13 into 21.5. Yeah. So let's say this is area 1. Yeah. Area 1, area 2, and this is area 3. And this is same thing with this area. Yeah. Area 4, area 5, and area 6. Yeah. Okay. Area 1, yeah, means, yeah, this is a triangle, yeah, a half of 1.5 times 2. Yeah, this is equals to 1.5, yeah, meter. Then area 2 is 2 times, this is from 1.5 to 6, means 6 minus 1.5 equals to 4.5, yeah, 4.5. So this is equals to 9 meter. And then A3, yeah, again this is a half of 1, yeah, times 2, yeah, yeah, this is equals to 1 meter. So total area or distance, yeah, height of this elevator equals to 11.5 meter, yeah. 11.5 meter, this is same thing with area A4, A5, and A6. Yeah. Okay. A A4. Yeah. A4 is, this is a half of 13 to 15 equals to 2. Yeah. 2. Yeah. Times depth V. So this is equals to V. Yeah. And then A5. Yeah. This is equals to 5 times V. Yeah. 5 times V, yeah, or equals to 5V. Then A6, yeah, this is a half of 20 to 21.5 equal 1.5, yeah, 1.5, yeah, times V. So equals with 3 over 4, yeah, with 0.75 V. With 3, yes. So this is equals to, with I calculate first, yeah, uh, plus 6, 11.5 divided answer. This is about 1.70. Yeah. So I will again, yeah. Sorry. Here, yeah. 11.5 meter equals to, after I calculate, this is about 6.75 V, yeah, and then we get V is 11.5 divided 6.75, yeah, this is about 1.70, yeah, meter second minus 1, yeah. That's it. Okay, finally we get about V, yeah, done. Okay, let me check continue. Let me continue other question. Yeah, other question. Done. Yeah, B question. Oh no, but C question. The combined weight of the elevator and passenger on its upward journey is 1,500 kilogram. Assuming that there is no resistance to the motion. Yeah, find the tension in the elevator cable on its upward journey, yeah, when the elevator is decelerating. Wow, I think we need to find the accelerating first when they have upward, yeah, here, upward decelerating. A, yeah, uh, like they have weight, yeah, mg, and they have tension drop, and this is decelerating means negative something, yeah. We see this, yeah, decelerating is on the 6 to 7. 6 to 7 is 1 second, and they have changed velocity from 2 to 0. Yeah, its mean acceleration is uh, 0 minus 2, yeah, divided 1. Yeah, so this is equals to minus 2. Yeah, meter second minus 2, yeah, this is about decelerating, yeah. So we can say this is 2, yeah, this is 2 meter second minus 2. So um when downward, yeah, sorry, upward, you know, wait. Oh yeah, upward but decelerating, yeah, this is upward. So it means, yeah, force is, yeah, this is total force equals to ma. Yeah, so T minus mg equals to ma. Yeah, uh, T minus, this is 100 g, yeah, equals to mass, this is negative 2, yeah. So T equals to uh, negative 300, 3000, yeah. So equals to uh, 12,000 newton. Okay, that's it. Let's check it where, if we have, maybe I have missing, yeah, I have missing about how to solve this question, yeah. I get 12,000 newton. I don't see about Max scheme, yeah. Maybe this is wrong from Max scheme. Let's check. Okay, again, please again to subscribe this channel, yeah. And we continue to the next number 5. A block of mass 5 kg is being pulled along a rough horizontal floor by a force of magnitude x newton, acting at 30 degrees above the horizontal. See diagram. The block starts from rest and travels to meter in the first 5 seconds of its motion. Find the acceleration of the block. Okay. Acceleration, uh, we use the data about from rest, so 2 meter in first 5 seconds. Okay, then acceleration is we use formula that v square, sorry, 2 meter, yeah. Oh, maybe we use s equals to ut plus a half at square, yeah. 2 meter equals to u in 5 seconds, and then a half a t is 5 seconds square. So 2 equals to, this is 0, yeah, a half, 25, 12.5 a. So a equals to 2 divided 0.16, 0.16 meter second minus 2. Okay, that's it, yeah. After 5 seconds, yeah, they have accelerating 0.16, 0.16 meter second minus 2. Yeah, that's it. Then question B. Okay. Given that the coefficient of friction between the block and the floor is 0.4, find x. Okay. 0.4 means as the frictional force here. So like we find first about frictional force is frictional force, yeah, equals to mu times n, yeah. So let's check again about normal contact force, yeah. Here we draw first about force, yeah, on the x direction. We have x cos 30, And on the y direction we have x sine 30 degree, and they have which, yeah, mass times gravitational, and they have normal contact force. Yeah. So on the x direction, actually we have, sorry, on the y, yeah, we have x sine 30, yeah, plus normal contact force equals to mass times g. Yeah. On the y direction, we have total force on the y equals to 0. Yeah. So you can see here on the y direction, yeah, on the positive one we have x sin 30 and r. On the negative one is mg. So we can decide as r plus x sine 30 minus mg equals to 0. Yeah. So r means, yeah, mg minus x sine 30. Yeah. Uh, m is 5, g is 10. Yeah. Minus x sine 30 is a half. Yeah. So this is same thing with 50 minus a half x. Yeah. Uh, we will use r this to find about x here. I move down about this. Yeah. Sorry. Here, yeah, but frictional force, yeah, equals to mu times r. Yeah. Equals to 0.4. R is 50 minus 0.5 x. So this is equals to 20 minus 0.2 x. Yeah. Okay, and then the total force on the x direction, yeah, on the horizontal direction is mass times a. Yeah. On the horizontal direction, we have x cos 30, yeah, and frictional force, yeah. Uh, x cos 30 minus frictional force equals to ma. X cos 30 is about a half root 3, yeah. Uh, and here is 20 minus 0.2 x equals mass is a and acceleration is 0.16. Is it correct? Yes, 0.16. Yeah. So okay, this is about 19.5. Yeah, we get x as 19.5 Newton. Uh, that's it. Mm. Okay, I hope you understand about this. Yeah, this is actually x. Yes, a half root 3 plus 0.2. Yeah, x equals to 20 plus. This is 0.8. Uh, 0.8 plus 20 divided the coefficient of x. Here. We get 19.5. Okay, we continue to the next number. The block is now placed on part of the floor. The block is now placed on part of the floor where the coefficient of friction between the block and the floor has different value. The value of x changed to 25 and block is now limiting equilibrium. Find the value of coefficient of friction between the block and this part of the floor. Mhm. Okay. So when different value of surface here, this is the coefficient friction between the block and the floor has different value. Then x change 25, a block no its limiting equilibrium. Yeah. So when they ask me, it's limiting equilibrium means total force, yeah, on the x equals to 0. Yeah, total force on the x equals to 0. Yeah, between first bit on the x is about uh, x cos 30, yeah, minus frictional force, yeah, minus frictional force equals to 0. Now x change 25, yeah, cos 30, so equals to frictional force, yeah, mu times r. So mu, we will find mu, then r is, if we see this, r is this one, yeah, um, here 50 minus 0.5 x, yeah, 50 minus 50 minus 0. Sorry, 0.5x. Then 25 cos 30 is 25. This is a half of 3, yeah, and equals to mu. This is 50. This is minus 0.5. X change to 25 here. So mu we will get as 0.57. This is about 0.57. Yeah, and coefficient is, there is no unit here. That's it. Or maybe for three significant figure, this is same thing with 0.577. Yeah, 0.577. That's it. Okay, done for this question. Yeah. And again, I need help you to subscribe this channel. Yeah. Don't forget to subscribe this channel. We have still two questions, number 6 and number 7. And so don't go anywhere. Yeah. So don't go anywhere. Let's check question 6. A particle moves in straight line. It starts from rest from a fixed point O on the line. Its velocity at time t as after leaving O is v meter second minus 1, where v equals to t square negative 80 power 3 over 2 plus 10t. Yeah. Question A. Find the displacement of the particle from O when t equals to 1. It's from point O, the particle is from rest. Yeah. Yeah, from rest. So maybe we need to integrate this velocity become displacement, yeah, because displacement means integration of velocity. Yeah. And from O to T equals to 1, it's mean start from 0 to 1, yeah, like displacement, or let's say we use x here. This is uh, integrate from A to B, yeah, of velocity in uh, in term of t, yeah, or integrate from 0 to 1, yeah. The velocity equation is t square minus 8t power 3 over 2 plus 10t, yeah, dt. We integrate this equation, yeah, this is of a third of 3 power 3, correct, yeah, negative uh, 3 over 2 plus 1 equals to 5 over 2. Is it correct? Yes. 5 over 2. Hmm, this is like 16 over 5. T, this is 5 over 2. Yeah, because integrate is like the power plus 1, yeah. 3 over 2 plus 1 equals to 5 over 2. And 5 over 2, 8 divided 5 over 2 equals to 16 over 5. Yeah, that's it. Plus 10. 10 divided 2 is 5. Yeah, t power 2. Yeah, plus constant. But we have like h here from 0 to 1. Yeah. Abundantly, we have the h is 0 to 1. Yeah. So, like, we change this is 3, 1, 3. Yeah. 16, 5, 1, 2, and 5. Yeah, this is negative of, yeah, equals to 0 actually. This is 0 power 3, yeah, 16 of 5, 0 power 5 over 2, and plus 5, 0 over 2. Yeah, this is something with 0, yeah. So I think you don't need to sign in, you don't need to write it. Yeah. And then whatever the power, yeah, from 1, this is equals to 1. Yeah. So same thing with this 1 over 3 negative 6 5 plus 5, yeah, minus 0. Yeah. So we have, how much is it? Yeah. Wait, I will use calculator. 1 over 3 plus 16 over 1 plus 5. Oh, sorry. 1 over 3 minus, yeah, 16 over 5 plus 5. 2.13. Yeah, this is 2.13 meter. Oh, okay. Then question B, yeah, is so that maximum velocity of particles is negative 125. Max minimum velocity is when the acceleration is 0. We find the acceleration first here. We find the acceleration first by differentiate of velocity. The acceleration is dv per dt or dv dt by the equation of velocity is this one here, t square e t plus 10t. Okay, we decelerate, we differentiate about this question. T square equals to 2t, yeah, minus 8 divided by 4, 12. T minus 1 is a half, yeah, then plus 10. And then equals to 0, yeah. A equals to 0, it means 2t negative 12 t half plus 10 equals to 0, or 2t minus 6t half plus 5 equals to 0. Yeah. So like we have t t this is t power a half means root, yeah. Oh, I know. 5 and 1, yeah. Like this is 5 and this is 1, because between 5 minus 5 times minus 1 equals to 5, yeah. Minus 5 plus minus 1 equals to minus 6, yeah. So t is 5 square, yeah, 25, yeah, second, or t equals to 1 square equals to 1 second. So we will use this time in 20 second and 1 second to find the velocity minimum. Yeah. We substitute v equals to 25 square negative 8 25 power 3 over 2 plus 10 times 25. Yeah, this is 6 to 5, yeah. Uh, minus, and this is 8 times 125 and plus 250. Yeah. So 625 minus plus 2. Yes, correct. Negative 125 meter second minus 1. Done. Okay. Again, don't forget to subscribe this channel. Yeah. If you have any doubt or if you have any question, please give a comment on the chat box. Okay, the last number is question 7. Two particles P and Q of masses 0.5 kilogram and m kilogram, yeah, respectively, are attached to the end of a light inextensible string. The string passes over the fixed smooth pulley, yeah, which is attached to the top of two inclined planes. The particles are initially rest with P on the smooth plane, inclined at 30 degrees to the horizontal, and Q on a plane inclined at 45 degrees to the horizontal. The string is taut and the particle can move on line of greater slope of the two planes. A force of magnitude 0.8 Newton is applied to P acting down the plane, causing P to move down the plane. See diagram. A. It's given that mass 0.3 kilogram and that the plane on which Q rests is smooth. Find the tension in the string. Mm, Okay. So we have two side force on the left on the right, yeah. When we have tension group in here, yeah, this is tension group on the mass 0.5 kilogram, yeah. This is tension group on the big bali, but we neglect about this one. And this is tension group on the mass m kilogram, yeah. But on the parallel with the plane, yeah, we have MJC, yeah, between 0.5 or on the mass, yeah. Okay, on the left side we have as the movement of this object, yeah, of this object, yeah, is go left. So like 0.8 plus 0.5 g, yeah, sine 30, yeah, yeah, minus tension drop equals to MA 0.5 A. So maybe this is 0.8 plus 2.5, yeah, 3.3, yeah, minus T equals to 0.5 A. Yeah, this is 3.3, yeah, because this is 2.2, 0.5 times 10 is 5, and sine 30 is a half of 5 is 2.5. 2.5 plus 0.8 equals to 3.3, yeah. And then on the right side for this one, yeah, uh, they have a tension group minus on this mass, yeah, we have mg sine, mg sine 45. So here is t minus 0.3 gravitational acceleration. Now sin 45 equals to ma 0.3 a. So 3 minus with 0. Sine 45, 2.12. This is 2.12 equals to 0.38. Yeah. So between this, yeah, 3.3 minus t equals to 0.5a, and this is t minus 2.12 equals to 0.3a, and we eliminate, yeah, with plus, so we can cancel about t, yeah. So this is 1.18 1.18 equals to 0.8a. So a equals to 1.18 divided 0.8. This is equals to 1.47. 1.47 meter second minus 2. And the t is, we can use between this here, or this. So when we use the first one, 3.3 minus t equals to 0.5 a is 1.47, yeah. So t becomes wait, 0.5, then minus, this is about 2.56, yeah, 2.56 newton. That's it. Okay, done. Continue to question B. It's given instead the plane on which Q rests in rough, and after each particle has moved a distance of 1.5 1 meter, their speed is 0.6 meter second minus 1. The work done friction in this part of the motion is 0.5 joules. Oh. Use the energy method to find the value of M. Um, I think we use the formula by potential energy loss plus work done by 0.8 Newton. Yeah, potential energy loss and work done by 0.8 Newton. This is become to uh, kinetic energy gain, yeah, plus this one, yeah, work done again friction, yeah, work done again friction. And potential energy loss is, we have two kind of potential energy between 0.5 g mg, and they have 1 meter distance in plane. Same thing with 1 times sine, wait, this is sine 30, yeah, uh, because they have like distance 1 meter. So the height, yeah, after 1 meter, same thing with uh, 1 meter times sine 30, yeah, 1 meter times sine 30, then minus, yeah, uh, mg mass g, yeah, uh, sine 1 sine 45 degree. Yeah, this is potential energy loss. Yeah. Potential energy on the mass 0.5. Yeah, this one. And this is potential energy on the mass m. Then after that, uh, plus work done, yeah, plus work done by 0.8 newton. Yeah, this is 0.8 times 1 meter. Yeah, because yeah, we have 1 meter. Yeah, as the distance. Yeah, and this equals to kinetic energy gain because they start from they until rest. Yeah, move distance the speed 0.6. Yes, rest in rough. Yeah, so final velocity is 0. Yeah, we can set this is a half mass. Yeah, 0.6 square. Oh, sorry, mass is both of them. Yeah, not only mass 1. This is 0.5 plus mass 2 times 0.6 square plus work done again friction is this one 0.5 joules. Uh, okay, this one is 2.5. Yeah, this is 10. Sine 30 is a half. This is 2.5 minus how much is it? Yeah. This is a half root 2. Yeah, maybe 5 root 2 of m. Yeah, plus 0.8 equals to 0.36. A half of 0.36 is 0.18. Yeah, 0.5 plus m plus 0.5. Okay, uh, I think we need to break it. Yeah, 0.18, 0.09 plus 0.18 and yeah. So this is plus 0.5. Yeah, this still 3.3. 3.3 minus 5 root 2 of m. And maybe I will change here this one 5 root 2. How much is here? 707. This is 707 m equals so plus 0.18. 7.25 here, 7.25 m. Yeah, and here is 3 minus 0.09 minus 2.71. So m we get divided. So Yes, 0.37, 0.374 in kilogram. Okay, that's it. Yeah, done. Six number we get done finally. And thank you very much for watching until the this video until the end. Yeah, and please don't forget to subscribe this channel, and you may to see other video on this channel. Thank you very much. Bye.